Welcome to this new tutorial where we will be creating a program on the Solana network to store information for a user profile using SolPG and a QuickNode RPC. The process we will do today will be similar to that described in the QuickNode guide on how to use derived addresses from programs in Solana Anchor, where the process of saving restaurant reviews generated by users is described. Our program will store user information such as nickname, description, profile image, URI, a level field, and their wallet address. The idea is to integrate this functionality with our Flutter app so that our wallet has a user profile on the blockchain. Let's get started. On beta-solpg.io, we will start by configuring our QuickNode RPC to communicate with the Solana network. In the wrench icon endpoint checkbox, we will select custom and there paste our RPC for the QuickNode DevNet. Now we will create a new project. We'll give it a name. Select Anchor Rust. We'll delete part of the code we won't be using, like the accounts which we'll create soon. And we'll change the name of our program to Profile CRUD. We will start by defining our QProfile data structure with the following fields: level, nickname, description, URI, and user with their respective types. For level, we will use a 64-bit integer. That is a large number. For nickname, description, and URI, we will use strings. And for user, the type will be public key type. Our structure will carry the account's label, since it will represent an account that we will serialize and deserialize in the process of reading and writing data on the blockchain. We declare a public QProfile struct, which will contain the context for the save profile function that we will later create. Remember that a context is the set of accounts needed in each function of our program. For this structure, we will add the derive accounts tag to add the required functionality. The first PDA account in this context will be QProfile with Q lowercase, and it will be an account with the QProfile data structure we have defined. We place the account parameter in this way, where we will define the creation parameters of the account in it if needed to initialize the PDA account. We set the pair parameter with the user. In this way, who signs and pays for the creation of the PDA will be registered in the pair parameter. In the space parameter, we will define the storage space in bytes that the account will use on the blockchain. The first 8 indicates the bytes of the default account discriminator. This is the minimum space that each PDA will take up. The next 8 we will use to define a U64 integer. Here we will store a level variable. The next 4 reserves space to store a length of the string that will be received, and we will calculate the length in bytes of this string, which we call nickname, with the nickname parameter. .len, the combination 4 plus string name. Len will be used whenever a variable length string is received. We make this same combination for the description and URI strings. And finally, we define a 32-byte space to store a public key. In the seed parameter, we define the seed through which we want to derive the address of our PDA. It is important to define here a combination that, first of all, use words and or numbers that are related to the purpose of the account to maintain a certain level of readability without complicating it more than necessary, but on the other hand, the seed is also not easy to guess by a third party. Secondly, include some public key to ensure that a unique address will be derived. In this case, we are using the public key of the user who is paying for the transaction. Using the user's wallet address, we can relate the PDA address where the user information is stored with their wallet address in order to query this data efficiently from the client side. And then we include this bump parameter to avoid collisions with other account addresses. We need to define a user account for our QProfile context, which will be the one who signs the transaction, and we will mark it as mutable or modifiable as follows. And finally, the system program account, which is needed to create new accounts in Solana. We need to place this instruction attribute with the parameters that we will be using to calculate the space of the PDA. Now we will create the QProfile update structure. We place the same derive account and instruction parameters that we created previously, and we will place the same QProfile user and the system program, with the difference that in the parameters of the QProfile account, we will place the mutee property for mutable, a realloc property that will serve to recalculate the space that the account will need, and we will add the same bytes that we specified for the previous context so that it recalculates the space according to the new information received. We will place the same seed we defined above. Since we will be working with the same account address where we originally stored the data, and again the bump parameter, and we will place the user as who will pay for the reallocation of space with this parameter, and finally this realloc parameter 0 to true to effectively discard all data previously stored. The last context struct that we will create will be QProfile delete, only with the derive account parameter. Here we will not need the instruction parameter, since we will not use any data to calculate space, since we will only delete data. Again, we place the QProfile user and system program accounts, and in the attributes of QProfile, we will place the mutable parameter, the seeds to calculate the PDA address, the bump parameter, and we will place this close parameter to which we will pass the account address of the user so that the account closes when this context is invoked. With our accounts ready, we are going to create our functions, starting with the save profile function that will receive as context the QProfile that we have defined in the following way, and the parameters nickname, description, and URI as string and level as U64. We define the QProfile account that we will take from the context in the QProfile account, and we will place the mod tag. We are going to display these messages, previous nickname and previous bio, with the nickname and description parameters respectively to illustrate the process of saving the data. Now we save each field that enters as an argument from the client in the corresponding fields of the QProfile account. The level, nickname, description, and URI as shown on screen, and in the user field, we will place the user account with its key parameter. Remember that we have defined it as the account that pays the transaction. Now we display these messages to demonstrate that the data saving process has been done correctly. We complete the function without returning value in the following way. For our update profile function, we just need to copy the save profile function and change its name and change the context for the QProfile update context that contains the specified parameters such as reallocation of space, etc. And finally, we will create the delete profile function that will use the QProfile delete context that will automatically close the account as we have explained above. We will display the message, the profile has been deleted. Now we have to run the build commands, obtaining this successful result, and then deploy our program. We must have funds available for the DevNet in the wallet connected to SolPG. With our deployed program, we can now use the SolPG platform itself. To enter information into our PDA, we go to the Test tab and deploy the Save Profile tab. Here, we will enter all the data that the function will use: a name, description, an image, URI, and any number for level. Now we must enter the accounts used by our Save Profile function as context. First, the QProfile. Remember that this is a PDA that is derived from a seed, Therefore, we select from seed. And this seed we will build with the QProfile string and as second parameter, a public key, which in our case, we will place the same wallet that we have connected to SolPG. The last parameter program ID is automatically placed and corresponds to the address that was created for the program when deploying it. With these data, we derive our PDA, and in user, we will place our test wallet again. By pressing test, we have written the information in the contract, and we can test it using the fetchAll function, and we see how it returns a JSON with the information we have written. We can also test the update profile function, to which we must enter all the parameters as we did before and place test. We see that in the fetch, all the data has been updated. In Solana FM QuickNode DevNet with our wallet address, we can see the update transaction and the messages we have programmed to display. Finally, we will test the delete profile function, to which we will place the associated address and our test wallet. After executing test, when doing fetch all, we see that the information has been deleted. If you've made it here, you have learned to create a Solana program to store information on the blockchain to retrieve it later. Subscribe, comment, like, and share with your friends so that many more people learn to develop in this wonderful blockchain, Solana.